Alright, geometry. Let's apply the law of sine and cosine. Let's use what we've learned, see what we can do with it. Alright, so for each triangle below, identify the method, Pythagorean theorem, law of sines, or law of cosines you would use to find each length x. For this first one, I don't see an x listed. I think they forgot to put it in there. So let's say I'm trying to find this value. Well, I have a side opposite a given angle, and I'm trying to find a side opposite a given angle. That would be the law of sines. Whenever you're given two angles and one side, okay, the law of sines is going to work. Here, I'm trying to find this x, and I'm given a side, an included angle, and another side. That would be the law of cosine. I accidentally put that one on there again. So here I'm trying to find x. Well, I'm given two sides. It's a right triangle, so the Pythagorean theorem will work. Alright, let's see what I have here. Well, I have two sides. I mean, I can do this one in a few different ways. If I look, first of all, I can solve for this angle right here just by subtracting from 180. Oops. This is 40 degrees. So I can use the law of sine because I'm trying to find the side opposite the 40, and I know this side and I know that side, so I can set up a law of sine ratio, or I can use the law of cosine because I have an unknown side with two sides and a given angle. Okay, all I need is the two sides and an included angle for the law of cosine. So we can use either. And this one looks like I'm looking for the side opposite that angle, and I know this angle. So that's only the law of sines. Let's see. Oh, sorry. Alright, so we've gone over the different types of triangles and what we see and what we need. So here it says, find the missing side length in triangle ABC. I'm assuming it means both side lengths because it didn't really say. So let's find x and y. So first of all, to find x, I'm going to set up my sine, law of sines, and I'll have sine of 75 over 2.93 equal to sine of 82 over y. Okay, cross multiply. I have y equals 2.93 sine of 82 over sine of 75. Okay, do your algebra. You can show your work on your notes page and figure out how I got to there. Okay? We did this lesson a few days ago, so I'm not showing every single step today. But if you just cross multiply and solve for y, you'll be there. I promise. So I got y equals 3. It's hard to read. So I'm going to put that in there. I also can figure out that third angle in the triangle by subtracting those other two angles from 180. So that's 23 degrees. So I'm going to set up the same ratio. Sine 75 over 2.93 is equal to sine of 23 over x. Cross multiply, I can do x equals 2.93 sine 23 over sine 75. 2.93 sine 23 divide by sine 75. And I get x equals 1.19. And I'd say approximately 1.2. That's silly. Here it was 3.0. Alright, so I used the law of sines because I had two angles given and one side. It wasn't an included angle, it wasn't anything, I only knew one side and two angles, and it wasn't 90 degrees, so the law of sines is all that works. Alright, how about this one? Looks like I have two sides and an included angle. So we know what we can use there. Two sides and an included angle means I use the law of cosines. So we have x squared equals a squared plus b squared minus 2 times a times b times cosine of the included angle. Alright, I'm going to push pause and do the math. Be right back. So here I got x equals to approximately 1.6. I use the law of cosines. I have a squared plus b squared minus 2 times a times b times cosine 16, and that gives me x. Well, square root of x, or squared, it's x squared, take the square root. Awesome. Alright, exercises 1 through 6. I'm going to go through them, but I just expect you to work through them on your own and check your work. Okay? So there we go. I needed to figure out this angle because law of sines works with the angle over the side, right? Then I can figure out this side and that side. Okay, two different calculations. Alright, try this one. I'm going to push pause. Alright, I used the law of cosines because I had two sides and an included angle. Added all the lengths together and got a total length of approximately 9.5 miles. Alright, next one. Go ahead and try it. First of all, to give you a clue, I found all the measurements of the inside of the triangle. Okay, to give you another clue, looks like I know that measurement, and that's it. Okay, so which law would you use? Alright, I'm picking the law of sines. Push pause, be right back. Alright, so what was the distance from the boat to each of the lighthouses at the time it was spotted? So the distance for the southern lighthouse is 24.2, and the distance here is 26.8. Alright, there's a pendulum problem in your problem set, so if you'd like to get a clue on that one, go ahead and work through this example. But a pendulum, 18 inches in length, swings 72 degrees from right to left. What is the difference between the highest and lowest point of the pendulum? Let's draw some lines here. Okay, so what I'm really trying to find is this would be the highest point, right, to the lowest point. So here's the lowest point, and there's the highest point. Okay, what I've done first, we can talk through this one a little bit. So at the bottom of a swing, okay, when it's down here, the pendulum is perpendicular to the ground, and it bisects the 72-degree angle. Okay, so the pendulum currently forms an angle of 36 degrees with the vertical, because it split it in half. Then by the triangle sum theorem, this angle right here would be 54, because we've got this perpendicular angle here. So sine of 54 will give us the length from the top of the pendulum to where the horizontal and vertical lines meet. So sine of 54 equals opposite over hypotenuse. Let's do that math. 18 sine 54 equals x. 18 sine 54. So x equals 14.6. And we're at inches. Okay, but we're not quite there. The lowest point would be when the pendulum is perpendicular to the ground, which would be exactly 18 inches. Alright, so down here, we're exactly 18 inches, because it's this whole string. So our difference would be 18 minus 14.6, which is 3.4 inches. What appears to be the minimum amount of information about a triangle that must be given in order to use the law of sines to find an unknown length? Two angles and one side. So two angles and at least one side. We'll say at least. What appears to be the minimum information that a triangle must have in order to use the law of cosines? Two sides and the included angle. That's it for today. Okay, good job.